So today we are going to start a new topic. First of all, last week we did uh, what was it we did last week? The
Widgets.
app widgets, no?
Yep.
So any questions, doubts about that before we move on?
Will you be going over the code for question 3? I changed it, but I'm not sure if it works without pictures because there are pictures.
Okay, yeah, let's do that. Let's do that after the break.
Okay, thank you.
Yeah. And anybody else? Who is 16478? You know who this somebody just joined our class here. The name is not there, only the ID is there. 16478. Okay. So today's topic is sensors. We're going to look at, all these devices that we use, the phones, even the tablets. They all have lots of different sensors. Okay, it's Reginald. Hi, Reginald. Welcome. So we will look at, different sensors. You have all used these phones and all, and you know that there are things that they can do. For example, you can play games in which you tilt the phone and it knows which direction it is tilted in. Or you can, the screen will dim itself if it's too bright, the light. If the light is too bright, it becomes brighter and it will dim itself in dark. All those things happen using a sensor. So we'll look at what different types of sensors are and how we can use them in an app. So I also have here something I wanted to talk about your group project, but I'm going to do it later on in the class. Maybe more people will have joined in. So for sensors, let's get started with the sensors. There are, yeah, broadly speaking, three types of sensors: motion, position, and environmental. And what we'll do is we'll do an overview now of these different types of sensors. Okay. So these sensors, here's they have a summary: GPS or network location, accelerometer, gyroscope. These are the actual names of the sensors. Let's see. Let's go on with the overview of the sensors. And like we saw in the first slide, broadly speaking, motion, position, and environment. So what are these different sensors? Motion sensors, as the name implies, they have to do with how the device is moving. For example, there are apps like on an iPhone. If you shake your phone and you're running iTunes, it goes to the next track or whatever it has been configured to do. So those kind of things is all done using motion sensors. And in this category belong accelerometers, gravity sensors, gyroscopes, and rotational vector sensors. We'll see examples of these in a moment. Then there are environmental sensors. And again, as the name implies, they have to do with detecting what's going on in the environment around you: temperature, pressure, light conditions, humidity. Not all of these sensors are present on all the devices, but these are the possibilities. Your phone can actually, measure the temperature if there is a temperature sensor in it. Position sensors. Okay. So this is made up of orientation sensors and magnetometers. So orientation sensor will tell you, typically used for detecting what orientation your device is in. You're looking at it in a portrait mode or if it's upside down, all those things. And also within this category of position sensors is, your GPS sensing also belongs in this category. So these are the different types of sensors that may be available on a device. Now, when you are using a sensor, when you're creating an app that relies on a sensor, there may be features of the app that are optional. There may be features of the app that you only want to expose if a particular sensor is present. So all of those things you can, program, you can determine which sensors are available, and depending upon that, you can, enable or disable features. And you have access to all these other things, like what is the maximum minimum range, what is the rate at which the sensor sends the data to your app. So these sensors can theoretically, at every few milliseconds, if you want, they can send you the information, the temperature. But if you are using an app in which you are displaying the temperature, you may not want to, have a data point every few milliseconds. That would be an overkill because the temperature won't change as fast. However, if you're programming a game, let's say one of those games in which you have those little metal balls that you have to go through like a maze and take it to the center, drop it in a hole. Those kind of things you may want every few milliseconds because you want to draw that thing and you want to change its position. So how fast to request and how fast to process data, all of those things are in your control. And of course, you can register and unregister for sensor events. Your app may not be listening to a sensor all the time, only when a certain activity, a certain view is being shown. So all of this you will have access to when you work with the sensors. These are the different types of sensors, as you will see the different names: accelerometer, gravity, magnetic field, orientation, pressure. So this is the entire list of sensors that are available. They're talking about here. Yeah, this is what I wanted to mention. Some of these sensors are hardware based and some are software based. So what happens is hardware based sensors give you raw data. For example, a temperature sensor can give you the data point of what the actual temperature is, and that would be a hardware sensor. But when it comes to, let's say, humidity, and humidity you measure in a certain way, you measure the absolute humidity, but along with, if you know that, you get the relative humidity. So there can be a sensor which is called relative humidity. There it is. See, measures the relative ambient humidity. So this relies on a humidity sensor and a temperature sensor, and it computes the relative humidity. That's why this is a software. So software sensors rely on hardware sensors and make a combination or do some calculation, things like that. Those will be your software sensors. This here says hardware. Rotation vector. So you get the idea. I may have given the wrong example, but there are these possibilities that some sensors are, can be either hardware or software. This will, for example, gravity sensor, you can using accelerometer, not just the actual hardware sensor which will do this measurement. When you're working with sensors, you have to be aware of how the Android operating system works with it. And there are different things, different components to it. So there is obviously a sensor. It could be a hardware or software sensor. This sensor produces what are called sensor events, meaning if you have a temperature sensor, the job of that sensor is to measure temperature and emit an event at the predetermined frequency, at the frequency you may have asked for it. So it will emit an event saying, okay, this is the temperature, this is the temperature, this is the temperature. It will keep on doing that. And then you have a sensor event listener. This is what you implement in your app. This listener is what listens to the events that the sensor is emitting. And how do you tie all this in? There is a sensor manager. This is a static object. And what you do is you have an instance of that available to you. And you tell this sensor manager from your app, you say, okay, that particular sensor, I want to listen to its events. And that sensor manager arranges all of that. So this is how the framework is. So there is a sensor which emits the sensor events. Your app will listen to the event using sensor event listener. And sensor manager is what gives you access to the sensors and allows you to say, okay, I'm listening to this event now. Okay. So this link is there in the presentation. You can also reach it through Google documentation. If you just say Android sensors, you will most probably find this page. You can read the most of it on your own. What I want to do now is I want to move on and we start using whatever they're talking about. We actually start coding and we start seeing it in action. Any questions so far?
Yes, good morning, sir. I just have a question about the sensors. They won't work on the emulator, right? So people who don't have Android phones, how do we test that?
Very good question. And good news is that Android emulator has emulated sensors. So I will show you how to use that as well.
Okay.
That's going to be there later on. Yeah, that's a very good question. How do we do this? And sometimes, for example, to test the app on a real device with a real sensor, you really cannot simulate a lot of things. You cannot say, okay, I want to see what happens in very cold weather. If it's not cold, it's not cold, or if it's not hot, it's not hot. Or humidity changes or ambient light change. Some of these you can actually, you can go into a dark room and see what happens. You can go to a bright room with an actual device. But the emulator makes it easier.
Yeah, that's true.
Okay. So today what we will do is we'll use two types of sensors. We'll see how much we get done today, and whatever is spillage will go into the next class. So we'll use the light sensor and a motion sensor. So light sensor, basically, as the name implies, you detect how bright it is or how dark it is, and you will make some changes in your app. So what we will do is we will sort of create a day versus night mode. We'll have a very simple app, and we'll change its the color scheme based on what the ambient light is. Has any of you seen an example of that in the apps you use?
Yes, in the weather app that I use, at night they'll have different images and stuff to illustrate.
Right. Yeah. And anybody else?
Yeah, it's usually on most of the phones as well. Like if you have like a little bit less brightness on your phone, and if you take it out, as soon as it's like very bright, the screen just dims up, but it just lights up.
Yes, you can see better. And in the dark, your eyes don't, it's not blindingly bright.
It's same with my laptop as well. Like it does like based on how much light the room has as well. So it automatically dims or lights. Yeah.
Yeah, MacBooks, they call it True Tone technology, I think, and they do that. So that's yeah, these are some examples. So we'll do that, as that will be our first exercise today, the light sensor. And in the motion sensor, we will implement something which is basically it's like a, it will detect how your phone is moving, rotating, and it will move an object on the screen based on that, just like you would in a game. So the first part of our activity today is basically it focuses on light sensor, but whatever we see, that is how you would configure any of the sensors, regardless of what sensor it is. The basic configuration is the same. Those things we talked about, the sensors, the manager, all of that we will look at now, how to tie all of that in. Okay. So why don't you all go ahead and start a new activity, use basic activity template. Then use always use your name in the project you create. Do that much, and then we will do these other steps. Basic or empty. I think I'm using empty activity in the presentation, but basic would work just fine as well. And we'll be using Java and Bolo. Okay, everybody up to this point?
Yes, most of us posted in the chats.
Okay, good. So basically, when you run the app, you should, right now, if you run your app, you will see a hello world screen, basically. Okay, mine is still loading. So this is the app I just created. It just says hello world right now in the center. Okay, now what we want is we want to, and this you could have had any app, does not matter. If you're using a brand new app, we could have built it on top of the app we did last time, or any other app really. So now what we want is we want this app to start listening to the light sensor. Okay. So these are the steps. We have to implement sensor event listener. We need the functionality of this event listener in the app. Since it is a very simple app, we can just implement this functionality in the same class, in the main activity class. But you can have a separate class. If you have a lot of complex things you want to do when the sensor event is received, you could implement it in another class and do it that way. Or you could do it inline. You can create the listener inline, meaning you implement all the functionality where you are setting the listener. So here, let's implement sensor event listener. So if you type implement sensor event listener, it will, well, you start typing and you will see the options. So this is what we want, sensor event listener. As soon as you do that, you should see that it is complaining. And how will you fix that?
Implement methods.
Huh?
Implement methods.
Yes. So in terms of, yeah, you can just, if you take your mouse, it gives you the option. You can alternatively, you can press Alt Enter and it will give you all these options. You say implement methods, it asks you which methods. And so these are the two we will implement: on sensor changed and on accuracy changed. Okay, so these are the methods we need to implement. What happens when a sensor event is received and what happens when the accuracy has changed. So this I will leave for you guys to do as a homework. When is but we'll look at the other one. So we have here process. This is what we will need to implement. Okay. Now we have implemented this, but how do we tell this app that you want to listen to the sensor, the light sensor, right? It's really simple, actually. All you need to do is you need to access the sensor manager and say, hey, get me a pointer to the light sensor and register this particular my activity as the listener. This because this implements the sensor event listener. So the way you would go about is, the documentation is always very helpful. This is where they're talking about identifying sensors and sensor capabilities. So we need access to the sensor manager. We need a class variable. We could class variable, declare class variable, and just get it from the application context. And if you scroll down, you will see further examples of how this is. Like, for example, here you are getting the sensor manager. And now you want to, let's say, listen to the sensor of type magnetic field, the magnetometer. So this is how you can check whether a particular sensor is present or not. So this will be useful, something like this. If you are using a sensor and in this list of sensors, you see, it tells you which API level a particular sensor became available in. So the one we are using, light sensor, it has been available since API level 3, Android 1.5. And our minimum API level when we started the activity, it gave us the default as 15. So there is no question that this sensor is available in the operating system. The question may be whether it is available on a particular device or not. So you may need to do that check. In our case, we are going to assume that the light sensor is available. We'll just use that. Otherwise, you can check this, the presence of a sensor. And this is a useful note. Android does not require. So different devices can have different configurations of sensors. Okay, let's declare a sensor manager and get a pointer to it. So in our class, we'll declare a class variable, private sensor manager. Okay, and this is where we'll get and you always this kind of setup to request a sensor and a pointer to it. You will do it in your on create. This is like the constructor of an activity. You don't have access to the actual constructor, but on create is called as soon as the activity is created. So this is where we'll get our sensor manager. So this is whatever it returns, we'll have to cast it. You'll see the code here. And we need to call the get system service. What service to get? It needs a static name here, context.sensor service. This will get us the sensor manager. Now what we need is the light sensor out of this. This sensor manager, it opens the doors to all the different sensors that are available on the device. We are interested in right now in the light sensor. So how will we do that? Let's see. So here there is a, the documentation is really good as well. For example, you can list the different sensors available. You can find out what is the make, what is the vendor, and if there is specific information that you have available in terms of what sensors can do what, you can use that. Okay, so this example here is pretty much, it sets the skeleton for what we are trying to do. This uses a light sensor, and it does, it gets you to the point where you're receiving the events, but it does not go beyond that. So we will go beyond that. So what we need is most of this code here. So far, what we have done is we have declared the sensor manager and obtained it. Now we need the light sensor itself. So this is sensor manager. What I want to do is one more thing. Let's take a step back and go and look at the documentation of the sensor manager. So as the name suggests, it lets you access the device, the sensors on the device, and it will give you access to all sorts of methods. Different types of sensors. What sensors, right? So these are all defined as static objects, integers, whatever the internal values are. And you can use these in the methods. So we want a particular sensor. There is a method get sensors, which will get you all the sensor, get sensor list. get default sensor of a given type. This is the method we are interested in typically. So if you want a sensor, light sensor, you will call this method and you'll pass the type, and types are those static ints that we saw. Int of sensors requested. So there is the entire list is here. You don't need to remember any of this. As you're typing, your Android Studio will do the job for you. These are the different sensors. If you want the proximity sensor, a lot of these have been deprecated. Okay, let's go back to the code. We are looking at the light sensor. This is where it is, the code is. What we want is, we want the sensor. All sensors have the same type, sensor. You can, from the name, you can infer, you can give it different names. And you can request it from the sensor manager, get default sensor, and what sensor? Sensor dot type light. So let's declare a sensor. I'm going to call it light sensor. And we will say light sensor is sensor manager dot get default sensor, and then it is the static type is stored. All of it is in sensor dot something, whatever sensor you want. So we want the light sensor. Once you have this much, at this point, your activity, when you run it, it has access to a light sensor. But right now, you have not asked it to start listening. So it has the object, but it doesn't do anything with it. So what we want now is, we want to now tell this sensor, or this whole framework needs to know that, okay, we know what the light sensor, the object is here, so we can access the data, but when will it be invoked? That part is missing. So we need to do that. So for that, what we need to do is, we need to register this sensor event listener, this activity, as the sensor event listener for this particular sensor. Let's see how that is done. So if you look at that, you can read the documentation of the sensor manager. There is a register listener and unregistered listener methods in it. What the register listener method does is, it tells the sensor manager that for this particular sensor, this is the current activity, is the listener, and at this frequency, I want the information to be sent. So it can be, normal, it can be faster, it can be slower, whatever the different options are for the delay. And this is usually done on resume. Anybody tell me what the difference is? Why are we doing it in on resume and not on create? And what is the difference between this? On create and on resume. It belongs in the app life cycle. About it in the introductory.
I think on create has to do, it's basically, it just occurs once, while on resume is every time you would visit that screen, you'll have on resume working. Maybe that's what. Like on create is only when the.
Can you please repeat?
Sure. So I was saying that on create is maybe something that only initiates once, and on resume, on the other hand, is every time that screen is open, or you come back to that screen. Maybe.
Yes, that's the right explanation. So on create, an activity may be created and it may go you move from that activity to the next. So it may stay in the background. It is in the background. Now, when it is in the background, you don't want those events. But when it comes back, you want to start listening. That's why you will see that on resume, you register it, and on pause, you unregister. Meaning when the activity goes into the background, unless you need that information in the background, you should unregister. Otherwise, you're making the device do unnecessary stuff. So for example, if your sensor here, it detects that the light is dim or too bright, and it does something to the screen, but only the screen in which this is. So if that screen is in the background, you don't want to be listening for it. And this is why we have these two methods here. On resume and on pause, they are a part of the activity class. And on resume is when we will register, and in fact, we will unregister on pause, so that we are being, they call it being good Android citizens, not hogging on resources unless you need them. So you are on this page, you can copy this code. I'm just going to type it because Android does most of the work anyway. The public wide protected. So it's protected void on resume. And what we want is it's complaining that we are not calling super.onResume, but I'm just about to type that. So super.onResume. And now what we want is we want to tell the sensor manager that we are going to register the light sensor we obtained in onCreate. So these are the options. Sensor. Okay, first thing is the listener, then the sensor, and the sampling period. You have more options. We'll just use this first one. So our listener is the current object. So this sensor is the light sensor we have obtained. So we'll type light sensor. And the delay. So for the delay, we need to look at the sensor manager and look for all the possible delays. So there is delay normal, delay fastest, delay game, delay UI. These are the various options. Fastest would be the fastest. Game is probably one level below, the numbering, you can see the values 0, 1, 2, and 3. So normal is the slowest, and that's good enough for us right now. So we'll go with normal. So what this does is, now what we've done is we have got access to the sensor manager, to the light sensor, and using that, we have registered this activity as the listener. Let's also, while we are doing this housekeeping work, let's also set up the method on pause, which unregisters the listener. Okay, so for unregistering is very simple. All we have to do is we have to just say unregister and pass the object. We don't need to say which sensor and what. It just removes this from the stack of listeners for that sensor. Okay, so far so good. Anybody have questions? Okay, so you should have this much in your activity right now. You've got, so what the system gave us when we created this activity, we have added this implement sensor event listener. So as soon as we did that, it gave us the option to add these methods, which we did. We haven't done anything in them. And we have registered the listener in the resume when the resume event is received, and pause is triggered whenever your activity goes in the background. If your app, the user, presses the home button or moves to another activity in your app. So we unregistered the listener over there. Okay. So right now, if you run the app, you will see that there is no change. We haven't done anything to the user interface or to the functionality. So it is running and it looks just the same. So let's see. Now what we want is we want to know if an event is being received. So anybody still working on this code? Okay. So we'll let everybody catch up, and then we'll see how the event is received, what data it contains, and how we use that. That's our next step. Can do is, right, we just want to see what let's say we just want to see if an event is being received at all. We could just print a log message here and say event received, and see that log message is being printed. That will tell us that the execution is coming here. We could also put a breakpoint and have the same effect. I prefer the log method because it will tell us how frequently it's coming, things like that. So how do we print a log message?
log.v or I.
Yes, that's correct. So we will just go with log.iv. These are different levels of logging: information, verbose, debug messages. You have access to a lot of DE, and depending upon what you use, when you're looking at the log, you can decide what level of messaging you want to see. So for example, you may have lots of information and verbose messages, but you are only interested in seeing the errors here. That's where this comes in, what method you use. So the verbose is the highest level, and assert is the, where everything is shown in verbose, all of these others. In debug, there are certain messages, log.v, they will not show, but everything else. What we want is we can go just log.I or v, and so that it shows up. And this requires two arguments. One is a tag. So tag, again, you can use to filter out things. So if you have different activities producing the log messages, and right now you're working on one, you want to see the log messages of only that, then you can declare, let's do that, private string tag, and let's call it sensor activity. Okay. And then over here, once you have and this can be actually static final. What is this static final? Difference between when we say static final and when we say it. Anybody?
I think static final which cannot change the value.
Final, yes, that would be the final, Sandeep.
Yes.
Final, if you try to change its value in the code, your compiler is going to complain that, okay, this is a final. What about static? When we declare a variable or method as static, what are we telling the compiler?
Maybe it can use it in subclasses.
So static, the declaration, when you declare something as static, what you're saying is that regardless of how many objects you create of that particular class, there is going to be only one. They will all share this variable tag or a function, meaning this is a class variable. So you can access it by saying main activity.tag without instantiating it. It's always there. And when it is there, it is just shared by all the objects of this class. That's what static does. And in a more real world example, let's say, you have, this is useful when you're creating, let's take a very simple example, a class called circle, and it's a circle basically. It may have a variable which is called radius, which defines the radius of the circle. And then it may have a static method called area, which just computes, because regardless of the radius, the area can be computed in the same way. It does not depend on the radius. So that method becomes static, meaning all the objects, they share that method, so not extra memory. Otherwise, what happens is every time you create an object, the system reserves some memory for those things that are non-static. So all of that memory becomes shared. It becomes more memory efficient. That's what the static is doing. And in our case here, it's a very simple one, but it helps nonetheless. So first thing, it keeps on complaining that I don't have this in my imports. So I can do an Alt Enter and it will get imported. It went there. That complaint is gone. And now we'll just print event received. So this is what is happening. Since sensor changed is called whenever emits the event. Presumably it's got a measurement of the current ambient light. Once you are at this point, and tell me what you see in your log.
You just keep log the message.
Keeps printing event received.
Yeah.
And you can see the timestamp, right?
Yeah.
How frequently is it doing it, approximately?
Oh, it's
very fast, right?
Yeah, pretty fast. Around like 0.5 second. Yeah.
So that's what is going on here. Let me see. I've run this now. I will open my log message, and right now I'm on error, and I'll change this to verbose. See 40 point, so in that range. 40 seconds, or at least 4. Oh no, it says identical 103 lines. So it is suppressing, the log is suppressing so many times the messages that are coming. So it is coming in very frequently. Okay, for now we will leave it like that. But what we are really interested in it is the information that we are receiving. So what is this sensor event? And how does it send us the information? So you see, regardless of the sensor, the type of sensor, this is the same method. So whether you're using the light sensor, we could have been using the temperature sensor, the humidity sensor, but the same event would be called. So how does it tell us the measurement that it just, that's what we want to find out. For that, we need to go to the sensor event documentation. So why don't you all open the sensor event documentation and see what it is, what is the information contained in this event and how we can use it. How we can get the measurement of whatever the light sensor is measuring. So when you have something, please unmute yourself and tell us what you found out.
I think that sensor even contains values of arrays. Like for example, if in case of light, there may be light as of one value and dark as of one value.
Mhm.
So for example, I've seen in GitHub like we can get like string dot value of event dot values of 0. So
Mhm.
use the one value. So we can store that value in an integer variable and we can check whether it is like greater than 225 or sorry 255 or less than that. Depending upon that value, we can consider it as a light.
Perfect. It's a good explanation. So what happens is that this event object we receive in this function call, it has a variable called values. So and these values, depending upon what sensor it is, this is an array of floating point numbers. And depending upon what sensor it is, you will know how many values to expect. So just, for our case, it is just one measurement. Now, if you were looking at the sensor that detects rotation of the phone, it will be movement of the phone it will have three values, one for each axis. So how much movement, what is the rate of movement, whatever it is measuring, it will be one for X, one for Y, one for Z. So you can, decide what to do with it. In our case, we are expecting only one value. So this is the thing we are interested in, values, right? And what you can do is I'm looking for the documentation. You can go into the sensor event, and hopefully it will have more details about that values property it contains, which is an array of floating point numbers. It's taking forever to load. Okay, we'll let it load. We'll come back to it. But the gist of it is that we are looking for the variable called values. And in the light sensor, the illuminance is in the first value, first element of this array. So let's do that. Okay, I'm seeing that event received. Okay. So we'll get the illuminance, and our variable is called sensor event. We've called it sensor event. So this is the first element of that. Okay, event received, and let's now make use of it. We'll print it here. This is the measurement we are getting. So that's the value that the sensor sent. Okay, let me see that. I noticed that more people have joined since we started the class. So a question, guys. I don't know if everybody's already here. We changed the time of this class from 11 o'clock to 10 o'clock, and an announcement was made, and I think many of you were asked by your friends who wanted that change over WhatsApp and stuff. So now I just want to make sure that all of you know that this class on Mondays will start at 10 o'clock, not at 11. So
Yeah, I just want to add in the WhatsApp group that we chatted was from the previous semester. So people who were not with us in last semester, they actually didn't know about that. But they probably received your email that said that the class will start at 10 instead of 11.
actually, the people who asked for that change, some of them were not in the last semester's class, so they knew, and the others who were not last semester, they were all here at 10 o'clock. So basically, I think they were aware. I don't know if there was a communication gap between the email I sent. I don't know how closely people monitor the announcements on Blackboard. Maybe something got missed. But I want to make sure that everybody knows that we are starting at 10 o'clock, not at 11. So today, some of you have joined, just joined, in fact. So Michelle is asking, how can the new students join your WhatsApp group? So can one of you, whoever is the administrator, please connect with Michelle and help her join the group? Okay, so Jagir is, said something, Michelle, you can text him the number in private and he will add you. And whoever else who is not in the group and wants to join and wants to remain abreast, please, coordinate with your other classmates. What we'll do now is we'll carry on and we'll have a break in a few minutes. And those of you who have joined late, if you want to catch up, you can stay in the break and I will help you catch up. Okay, so at least after the break, you will be with the class. You will not have missed anything. So Michelle, to text it, you will open in your WebEx, open the chat. You may have, where you have it open. Just change from send to everyone. Instead of that, you send it to Jagir. He's asking, so if you change that, then it will go just to him. Okay.
Sorry, to who?
To send it to Jagir.
Okay, thank you.
He's the one who messaged in the chat before to send it to him. Okay, so let's carry on here. We have just added this line. We are going to print this illuminance, and we'll watch what it is printing, and then we will break. And those of you who want to catch up, just stay during the break. So, after the break, we'll see how to change that, how to play around with in the emulator, the sensors. So for now, let's take a break here. We'll take a 20-minute break. It's 11:10 roughly. We'll resume at 11:30.